We will discuss Kruskal-Wallis test in SPSS. Kruskal-Wallis test is a non-parametric test used for the samples originated in the same distribution. Kruskal-Wallis is used for comparing two or more samples that are independent and that having different sample sizes. Example, a car driver want to know the difference in the average mileage given by the three types of petrol. In our SPSS file, I have two variables, the petrol and the mileage. For petrol, I have three values, petrol type 1, petrol type 2, and petrol type 3. For petrol measurement, it is nominal, and for mileage, its measurement type is scale. If the data is not normally distributed, we should use the Kruskal-Wallis test. Before we go on, let me have my null hypothesis. The null hypothesis, the distribution of the average mileage of petrol is the same across the three types of petrol. Decision rule, if the significant value is greater than 0.05, then retain the null hypothesis. Let me perform the analysis. First thing, click Analyze. Go to Non-Parametric Test. Click Related Samples that I'm going to feed petrol type as a group and the average mileage as a test of field. In the settings, I want to use Kruskal-Wallis one-way ANOVA. Then press Run. The data of the average mileage of petrol is the same across the categories of the types of petrol. The significant value is 0.04. If significant value is greater than 0.05, then retain the null hypothesis.
So welcome to today's tutorial. So today we're going to talk about how to use Mann-Whitney U-test in SPSS. So Mann-Whitney U-test can be also called as Mann-Whitney-Wilcoxon test or the MWW, the Wilcoxon rank sum test or the WRS, and the Wilcoxon-Mann-Whitney test. So what is Mann-Whitney U-test for? So it is used for comparing the sum of ranks of two independent groups. So to explain that, I have here my SPSS with my recorded data as an example. So as you can see, I have two different independent variables. So the first one is the salesperson and the second variable is the sales. So for the salesperson, I have 2, which is numbered as 1 and 2, with its corresponding different number of sales. So again, to review, Mann-Whitney U-test is used to compare the sum of ranks of two independent variables. So as you can see here, I have the first variable as the salesperson and the sales. So each salesperson has a corresponding sale, which is an independent variable. And in this example, it is assumed that all the observations from both groups are independent of each other. So that's the first assumption. And for the second assumption, the responses are ordinal or interval data, which means it's not normal. So as you can see here, my data is interval, not ordinal, and they are not normally distributed. So which means that under these two conditions, we would be using the Mann-Whitney U-test. So for the null hypothesis, there is no difference between the performance of salesperson 1 and salesperson 2. So I'm going to see whether I'm going to accept this or reject this hypothesis by using the Mann-Whitney U-test. So as you can see, this is the salesperson data with its corresponding sales or sales performance. So for the first step, click the Analyze button, then go to Non-Parametric Test, and we have the one sample, independent samples, related samples, and legacy dialogues. And click the legacy dialogues and select two independent samples. So first click the salesperson and click the arrow and do the same to this sales. Then click the define groups, and as you can see here there's group 1 and group number 2. So click continue, and then you can see here the test type. So we should make sure that the man Whitney U is checked, and then click OK. So here it will be displayed. There is a table that would display the ranks. So as you can see here, there is the sales and the salesperson data and the sum of ranks. So the first salesperson has a sum of rank of 143, and the second salesperson has a sum of rank of 47. And we can easily understand that there is a difference between the two salespersons. The question is it significant or not significant? So below is the test statistics that would identify if the test is significant or not significant. So as shown in the test statistics, it is 0.000. So if the significant value is less than 0.05, then we should reject the null hypothesis. Since the significant value is 0.000, then this leads us to the conclusion of rejecting the null hypothesis. So for the null hypothesis, there is no difference between the performance of salesperson 1 and salesperson 2. So since we are rejecting this null hypothesis, there is a difference between the performance of salesperson 1 and salesperson 2. You can see again the significance value is 0.00, and since this is less than 0.05, so we would reject the null hypothesis, and this would lead us into the conclusion that there is a significant difference between the performance of salesperson number 1 and salesperson number 2. Welcome to another tutorial. So today we're going to talk about how to use the Wilcoxon signed rank test in SPSS. The Wilcoxon signed ranks test applies to two sample designs involving repeated measures, matched pairs, or before and after measures. That's why the Wilcoxon signed rank test is also called the Wilcoxon matched paired test. And Wilcoxon signed rank test is a non-parametric test that can be ordinal or interval. And the Wilcoxon sign rank test data should be not normally distributed. So let's have an example. Here I have 10 employees, and in this data their scores before training and their scores after training are recorded. So this data is an interval data and it is not normally distributed. For the null hypothesis, the null hypothesis is that the median difference between pairs of observations is 0, or there is no difference between the scores of the employees before training and after training. So the first thing we're going to do is click the Analyze button, and as you can see here, we have many options, and click the non-parametric test and the legacy dialogues. And lastly, click the two related sample option. So what we're going to do next is we're going to pair the sample, the score before training and the score after training. As you can see here, they are already grouped in a table. So first, we should make sure that the test type is already in Wilcoxon, and then click OK. Now we can see the results of the non-parametric test. So as you can see, 5 employees has lesser scores in their after training than before training. 4 employees has greater scores in their after training than their before training, and 1 student got an equal scores between the after training and before training. And as you can see, the mean of the score after training is 4.40, and the mean of the score before training is 5.75. So as of now, our goal is to identify if there is a significant difference between the scores before training and scores after training. So we would look at the significant value. So our significant value is 0.953. So there is, in the conclusion, if the significant value is less than 0.05, this would lead us to rejecting the null hypothesis. But since the significant value is 0.9553, we would be accepting the null hypothesis. So in conclusion, there is no difference between the scores of the employees before training and after training.